Hello everyone. So the next step of problem is analyze the given frame by slope deflection method and draw bending moment diagram. Okay. So here again, the frame is little bigger, but then all the steps and all are same like before. Okay. It's just that it is lengthy, but all the concept and all logic and all applied is just like before. Okay, so what they've told here is end A is fixed. Okay, this is a frame, and E, F are also fixed, and D is a overhang. CD is a overhang. Okay, again, just by seeing the problem, you can conclude whether it is a sway frame or a non-sway frame. Okay, now see here, end A is fixed. Okay, even though if I apply any load here, it will not move. The reason why is because this end is fixed. Because this end is fixed, it will not allow the lateral movement or horizontal movement of the complete frame. So now I'll term it as a non-sway frame. So it's a non-sway frame which will not move because of this fixed support here. Okay, and there is a point load which is eccentric, and there is a UDL and span BC, and there is a load here. Okay, and this I is only I here and the BE, and in CF it is 2I. Okay, so all the other dimensions are given. So as usual, first we'll find out the fixed end moments, slope deflection equation, joint equilibrium equations, followed by final moments, then marking and drawing the bending moment diagram. All the steps are same. Okay, all right, so first fixed end moments. So MFAB first. Let's start from always from this end. So MFAB is equal to, it's eccentric here. So it is WAB square by L square. Okay. So A here is the longest span. So it is 3 minus 2 is 3 minus 1 is 2. Okay. And B is shorter span 1. Okay. So it is WAB square by L square. And MFBA. Okay. MFBA is MFBA is plus W A square B by L square. Okay. All right. Next. This is one. Find out. Substitute the values and find out. Then you got MFAB, BA. Next is BE. Okay. So here MFBE and MFEB. There is no load only in this column. So obviously MFBE is equal to MFEB, which is equal to 0. Next, MFBC. Okay, you can see here MFBC is equal to minus WL square by 12. Minus WL square by 12. Substitute the values. MFCB would be plus WL square by 12. Next, MFCD. So because it is the left joint. So left joint will always have minus sign in it. So this is considered, this MFCD is equal to minus force into its perpendicular distance, because joint D is a overhang. So there is no supported D. So it is only force into perpendicular distance. Okay, so 30 into 2. And at C, because it is left joint start point, so it is minus 30 into 2. Okay. Then MFCD, MFCF is equal to MFFC, which is equal to 0. Was there no loads only acting here? Okay, once you find out this, next is slope deflection equation. Second, slope deflection equation, again same. MAB is equal to MFAB plus 2EI by L. A is the first joint, and so 2 times theta A plus theta B. And of course, there is no settlement, so you no need to write the formula. You can straight away write it 0. Okay, MFAB you have already calculated here. This portion plus 2EI by L, and always be careful when you're taking the value of I. Some spans it is I, and some spans it is 2I. So you should carefully resolve this. So theta A is the fixed support. So because the fixed support, it becomes 0. Okay. So MFAB plus 2EI by L into theta B. So this is equation number 1. Okay. Similarly, MBA is equal to MFBA plus 2EI by L, theta A plus 2 times theta B minus 0. So we get the value of MBA. This is equation number 2. Okay. Then MBC. MBC is equal to MFBC plus 2E, instead of I, substitute 2I by L, 2 times theta B plus theta C, okay, minus 0. Okay, now see here, again, you can, just by seeing this, you'll get to know, end A is fixed, theta is 0, theta E is 0, theta F is 0, so there exists only theta B and theta C. Theta D will not exist because it's an overhang. There is no support only here. So only exists as theta B and theta C. Okay. So MBC, you get this value. Similarly, MCB is MFCB plus 2EI by L, theta B plus 2 times theta C minus 0. Okay, so this is MCB. MCB. So MCD is equal to minus 60. Okay, we have already calculated this. Minus 60. CD is the first joint. So it is anticlockwise minus 30 into 2. Okay. Next, MBE. This then we'll calculate MBE, EB, MCF, FC. So MBE is equal to, substitute all the formula, and theta is 0 here. Okay, in those two joints. So there exists only theta B. Similarly, MEB, so it is theta B plus 2 times theta E is equal to 0. So ME is equal to only theta P values. Okay, next MCF. MCF, it is this joint. CF, FC. So C will exist, F will not exist because F is a fixed joint. MFCF plus 2EI by L, 2 times theta C plus theta F. We are left with only 2 times EI theta C. Similarly, MFC is MFC 2EI by L theta C plus 2 times theta F. Again, F is a fixed support, so it becomes 0. So once you write all the equations, next we'll write the joint equilibrium equations. So joint equilibrium equations, we'll consider this joint. MBA plus MBE plus MBC is equal to 0. That's the first equation, joint equilibrium equation. Next is MCB plus MCF plus MCD is equal to 0. That is the second equation. So we'll substitute all the equations here. We'll add all of these and again rearrange it in the form, rearrange and simplify in the form of theta B first, theta C, then followed by a constant. Similarly, at C, MCB, MCD plus MCF is equal to 0. Again, write the equations here. Be careful with the signs here. Be very careful with the signs. So again, keep it in the form EI theta B plus EI theta C minus a constant value. So these are the two equations. Now put these equations in the Cal C and solve this, and you'll get the value of EI theta B and EI theta C. Again, be careful with the signs, theta B and theta C. Okay, after this, calculate the final moments. Okay, after this, calculate the final moments. And the final moments are MAB. MAB is equal to, substitute in the given equation, substitute the value of EI theta B and EI theta C along with the sign. Okay, so what is the check here is, again, at B, there are 3 joints meeting, 3 members. At this joint, 3 members are meeting. So all the 3 moments will not be same. So I've already told you, whenever the member, there are 3 joints, 3 members meeting at one single joint, then the bending moment would be different. So you can see MBA is different, MBC is different, and MCB is different. Okay. Then MCD we have already calculated. Similarly calculated MBE, EB, substitute back all in the previous equation, all the slope deflection equation, and calculate all the given equation. Okay, once next thing is, we'll draw the, okay, I've again told you dotted side, how to draw this dotted line. You can see here, first draw the given frame like this, the bold lines. Then on the inner side of the bold line below, draw the dotted line. Again, on the inner side below, draw this dotted line for this frame. Below the beam, and right side inside the columns. You have to draw the dotted line. Again, why I've told you to draw the dotted line is dotted line shows the tension side. Tension side means positive side of the beam. That's why you will write it as dotted. Okay. All right. After this, then we'll start marking the bending moment. Okay. So first is 8 point, how much is MAB is 4.06 plus. So plus means clockwise. So show it like this. The arrow should always be actually touching this point. Okay, clockwise. Next, MFBA. BA means draw it here only. So it is again plus 25. So clockwise. Then MBC is anti-clockwise. You can see here MBC is anti-clockwise. So in BC span, show at B here for minus this thing. So it is 42. Okay, and MCB is again plus 68.35. Next, MBE is how much? 17.0 BE. Okay, so it's a positive. So positive means show it like this. Okay, clockwise. It should actually touch the column. Then EB is also positive. So show it here. Next, MCB is anti-clockwise minus. CD is again minus means anti-clockwise. Then MFC is minus 4.7. So it's minus means show it like this, anti-clockwise. And MCF is again minus 8. So minus and show it anti-clockwise like this. Okay, once you show this, next is drawing the bending moment diagram. Okay, so first draw the free bending moment. Wherever there is load, just draw the bending moment for that. Okay, so free bending moment is first AB, there is a point load here. So WL by 4. AB, WL by 4. So it is 15 kilonewton, mark here. Then BC, again it is a UDL. So it is 96, WL square by 8. So it is 96. Okay, so mark these. Okay, next is AF, draw the fixed end moment. Okay, so fixed end moments. For beam, remember one thing, whether it's positive, negative, always you should draw above the beam line. So this is the beam, you should draw above. Because your bending moment also you're drawing here, free bending moment. Okay, so it is now first is 4.06, 4.06 above this, plus. Next is after this immediately, it is 25. So first you have to show here 25. Okay, then at the same point, there is also in this span of the beam, it is 42. So show here 42. So this is 25.76. This is 42.79. Okay, first mark this like this, then draw a straight line. Okay, because at that same point, you're getting two bending moments, two different types of fine line movements. That's why. Okay, then come to this point that here it is 68. Then first show maximum here, 68. This you have to show. And in this part of the beam, it is 60. So reduce it, make it 60. Then at D, it is 0 because D is a simply, it's a free overhang. So 0, so mark this. So this is the line you have to mark now. Anything above this portion or this portion will be positive. You can hatch it and make it positive. Okay, next. Again, now so I've always marked this bending moment in the supports first. Okay, in this portion it is EB. EB means it is bending like this. So it is bending on the tension side. Tension side means positive. So it bends here. So draw it here inside. So inside means this is plus. This portion is plus. Next, similarly, this is plus here. Here it is trying to push it out. Okay, push it out means you have to show it here, this portion like this. So it is plus here, minus here. The magnitude is 17. Okay, similarly come back here, this portion. So it is trying to push it again towards this side. So it is trying to push it inside. Inside means positive, plus. So it is 4.17 here. Okay, 4.17. Then in this portion, it is trying to push it out. Out means away. So it is 8.35. So this is outside 8.35. This is now plus and this is minus. Okay. So in the end, we all connect all the members. Okay. We connect all the members in the joint and draw the free bending moment, and then mark all the final moments at all the points, and mark these also here. So this is plus, plus, minus, minus. Anything which comes inside the frame, the values which come inside the frame are termed as plus, outside minus. But for beams, we always draw the positive and negative side bending moment on the upper side only. Okay. All right. So this is how we solve the non-sway problems. So in the next class, we'll start with the sway problems. That is little time consuming. So you have to be very careful. So first finish off with this sway type of non-sway type of problems, because it's a little simpler. Okay. So that's all for today. Thank you.